Hello and welcome to What's New in NX85 Part 2, a webinar by Sherpa Design and Applied CAX with me, Matt Martin. I'm going to review Unite with Regions because it's so cool. We'll get into it. So you pick my Unite tool, select the target body. I'm going to select all of these fins, strengthening ribs to place in there, and this other pocket on the end. What I want to do is define the regions to either keep or remove. In this case, it's much easier to pick the geometry I want to remove. And I grab all these outside edges, or outside pieces. You can see in the preview window that it's giving me an idea of what it's going to try and remove. And I say OK there, and instantly I get multiple features rolled into one, and that's a very cool tool. There's a new expression locking. You can filter by feature and expressions, and some helix enhancements I'll cover here. First off, just real quick, get into expressions. I want to take the height here and I want to lock it. Just lock the formula. You get an icon there that says you can't just edit it. Next, I want to filter my expressions and work through trying to find expressions in different ways. So all is obviously all. I can filter by name. And it is case sensitive, so if I put a lowercase l in there, it doesn't find it. Put the uppercase L in, it finds it again. It also remembers your last few commands that you put in there. You can filter by formula, string, comment, expression type. So there's expression type. Obviously number is all your expressions again. Well, most of them anyway. And filter down through the list, find the things that you want to easily pick out of the expression editor, and there they are. And object parameters, of course, has been there for a long time. Unused expressions can be handy if you're looking for any expressions that you haven't used yet in your model. Okay? The helix tool is greatly improved. You've got a lot more control over how to build a helix in modeling. You can run it along a vector or along a spine, and it wants to have a CSys to start building it off of. So I'm just going to dynamically throw a CSys out here. See that it's all really building the helix for me already. I can control it by radius or diameter, and you get a lot more control over how to build your helix. You can control the size and pitch. With law curves, with controlling it along a spine. You can see here that I can control the start angle. I've got a drag handle, I can drag it around. Key in the value, throw 0 in there. And I can also control either limits or turns. And of course I have my drag handles, make it taller, shorter. Switch it to a number of turns, edit that down to 20, 10, and go back to limits. You can also control the handedness, either right hand or left hand, and you have a distance and angle tolerance that you can control in there too. You want to make a flat helix. I obviously need to have a control the size. And again, you can control that linearly or with all the other law controls that are in there. And this one shows that I'm on limits here, and switch that to turns, and there's a flat helix. Again, I can control the start angle. Let's get into some of the cool features here. So I'm going to control this helix with a spine. I've got the size set at a constant 100 millimeters, and I've got it cubic along a spine, and I just have a line down there in the bottom of the screen. I can place points on the line where I'm going to adjust the pitch, either keying it in on the screen, or I can drag the handles themselves. Of course, I want a point on each end of the spine to show 0 and 100%. I'm going to key in 50% here and watch the helix update. 80. You can also drive a helix along a 3D spline. There's my helix, follows a 3D spline. Go ahead and edit that helix, and I show that it's along the spine, and there's my spine control. You can extend the helix past the end of the spine, and it'll continue along on that same vector that it was at the end of the spine. And of course, I'll edit the control spine. And show how that affects the 3D spline, or the 3D helix. And here's one where I'm using variable pitch and size control with a long spine. I use the same spine for both, and I did size linear along a spine and pitch was cubic along a spine. The spine itself can get pretty packed with points. You could use different control spines for each, either pitch or diameter. Pitch or size, rather. And there's helixes. So in mirror feature, there's an enhancement to allow thread-handedness and some enhancements with drafting. I want to mirror feature this threaded feature here in the corner of my enclosure. Grab that extrude and then grab that symbolic thread there. And I want to maintain thread-handedness and build a bisector datum across there. And the threads that are here are the correct handedness. I also want to do a mirror feature where I'm just going to take certain instances across to the other side. There's a fan cutout over there on the other side. I want to avoid that. So I can pick the pattern instances right off of the model tree here. I can see that instance, what did I say, 5, I hold down Control and I can grab the rest of them in that column there. And there's another 5 there, 6, 7, and pick them all this way. This can be a little on the tedious side of picking them individually like this. But each one is starting with instance whatever and then 5 to give me the 5th row up. And I'm speeding things up here a little bit. Pick a plane, go, and I've mirrored only part of the instance feature to one side. Now I want to clock one hole just to show how that's going to work. Clock it right here on the screen. Gives me drag handles. I'm going to drag it up 4 millimeters. Say OK, and then the mirrored hole also clocked over. Draft enhancements. Pick my draft tool. Give it a vector. I'm going to pick a point dialog here and just go a point along an edge here. It automatically inferred based on my draw direction, and it's going to give me a datum plane on the fly. Essentially picking the parting surface there. And switch it to parting face, same thing, pick a point. And now my parting line is based on that point that I picked on the edge. Do it from a non-planar surface. Give it a vector, pick the surface. Then pick the some interesting geometry here. Pick the faces that I want to draft. Tilt to draft both sides. And this is a parting face, so drafting both sides would make sense. And hide that, and you can see how it's drafted. You can also draft from multiple faces. Make sure I pick body faces and grab all of the ones of that body, all of the faces of that body. And my preview is on, so it's showing me how it's going to interpret that. Get rid of that and do it again with a parting face. Draft both sides. And throw in a bigger angle so we can really see what's going on here. Hide that parting face here. Okay, go into Assign Feature Color and Emboss Body. Now you can assign a feature color. I'm going to right click on that and assign feature color. Comes up with no color on it because there's no color on it. I'm going to apply a color, say green. Now that edge blend feature is green. If I go in and edit that feature, add another edge in there, the new edge is going to also be green. The feature itself owns the color. So if I add more to that feature, more ends up in that color. I can also assign a feature group color. I found that the updating on this one sometimes is not necessarily intuitive. But I applied a feature color, a feature group color. I want to add that pattern into the feature group and see that the pattern itself also inherited the feature group color. So here's a swept enhancement. Pick my swept tool, Give it a section curve. Give it a guide curve. I'm going to split output along a guide. And you'll see here that it's actually splitting the sheet body that I've created and splits that output along the guide. Keeps the same number of faces, and that could be important. So here's embossed body, and this is another just amazing tool. So I have a plastic base here. Let's say this is a dog bowl base. Turn on the dog bowl, and you can see the interfering faces there. Section it so you can really get a good view of it. This command is called emboss body. So insert, combine, emboss body. Give it a target. Give it a thickness. And then I'll pick the tool. And I want to keep that tool because I want to see what it looks like after I'm done with it. And it looks like it's done, and I rotate it around. You can see that the topology inside has changed. And section this, you see that it's following the shape of the bowl. And those faces were touching, so I'm going to go ahead and give it a 2mm clearance in here. And now my clearance has been added. This is an amazing tool here, the Open Smart Volume. It's kind of a different way of thinking about how to build a feature. So I'm going to extrude this sketch that I have on my part file here. It creates a sheet body until I pick Open Smart Volume, then it's automatically inferring what I want it to do. That's pretty cool. It also works on revolve. So pick the curves, give it a vector. Revolve doesn't have an inferred Boolean on it, so I switch it to unite, and voila, it's done. There's a new point set type. I'm going to cover some feature dimensions, and this little part is a little bit out of order here. So insert a point. If I wanted to create an intersection point between that surface and a spline, I pick the surface, and then I pick the spline, I pick the geometry I want to make an interferent or an intersection point for, and it tells me that I get multiple intersections found, and that's because there's multiple intersections there. If I want to create a point on every intersection through that surface, I can grab intersection points. Again, I can grab the surface there. I can also grab more geometry than just one spline, and it creates a point set that's in my history tree. Now, feature dimension, they've added more things that feature dimension works on. If you go to edit feature dimension and select the feature itself, it brings up this window. You can see the dependencies. You can also edit them right on the screen. I can display something as PMI. Shows that they're they're not updated yet. They really just added this to more features, and here it is on a chamfer. So edit this, make it a 6, and that's updated. Global shaping. If you haven't seen this tool, it's pretty amazing. So here I've got a bootstrap, let's say. I'm going to edit surface, global shaping. And the two new ones are by curve and by surface. This is a by curve example. Make sure I pick body faces here. Grab the body. I'm going to select the base curve. And I'm going to select a control curve for it to go to. The preview is pretty faceted, and sometimes it's hard to figure out what it's trying to tell you. And go ahead and give it a twist from 0 to say 90 degrees. I want to tell it to keep the base length. I'll switch that back and forth here. You can see how the preview is updating. And I also have below the input sheet is going to be retained. So it's taken the body and reshaped it based on the control spline. You can also do this by surface. Global shaping again. I'll switch this to by surface. Make sure I have body surfaces picked. And I want to transfer this shape here to this barrel shape on the other sheet body that I have here. You have to be wary of the U and V parameters. This one took a few different attempts to get it to do exactly what I wanted it to do. If you look at the preview and see that that's not really what I wanted to go for, so I have to flip to normal on it and make sure that the deformation direction is set properly. You can either do an innie or an outie once it's set there. And I also want to keep the input sheet here to compare the two. Say OK, and there is my part transferred over. And just show it all on its own. That's pretty cool. Some synchronous modeling enhancements with notch blend, move face, and the way the faces adapt, and deleting a partial blend. Notch blend is a blend, a rolling ball blend that is missing a vertical component, a tangency component. So I labeled that notch blend. I'm going to go in and move these faces, and you'll see here that it's already calculated where that tangency is going to happen. I have two notch blends, on one is shown and one is not, and you can see that the behavior is pretty drastically different. On the left there is not a notch blend, or not labeled as a notch blend. So move face has some enhancements to it, in that if I wanted to move this boss over and have it intersect with that lower flat face, I drag it out here and my face cuts off. The motion face has been consumed. Now I could do is a cut and paste face in the past, and that's been added to the move face dialog. So let's do this again. Pick the same faces. Give it a vector. I'm going to change this to cut and paste. And I want to tell it that I want it to automatically paste the face when I'm done moving it. And drag it out. Click OK, it recalculates, and there's my updated face. I've got a body here with a step face, or rather it's going to be a step face. I've already divided that top face up there. If I just go to move that face, I get all kinds of errors and it just does not like it. So I'm going to tell the step face to extend neighbors, and the behavior changes. If I switch this to extend cap face and turn off the step face portion of it, you'll see a different behavior. It's a different way of controlling moving a face. So deleting a partial blend. If I just delete this face here, it calculates out and kind of gives me a flat delete. If that's not what I wanted, I can tell it to delete just a partial blend, and I'm just deleting that one segment of blend in the part file. I'm going to delete face with an explicit cap and specify a plane. Oh, that plane's in the wrong direction. Flip that over. So I just picked that one middle blend face. So as I move this datum up and down, you'll see how it's deleting it. So please stay tuned for what's new in 8.5 series. I've got drafting coming, Shape Studio, sheet metal. Thank you for joining my webinar. This has been Matt Martin for Applied CAX.